and welcome to Learn ADS in 5 minutes. This is Tutorial 33 on EM simulation of imported Gerber file in ADS. Before we get started, a simple request. If you like the videos posted on my channel, I would recommend you to subscribe the channel. And once you subscribe the channel, click on this bell icon to enable all the notification. Lastly, after you watch the video and you like the content, please press the like button and share it with the rest of your colleagues or friends who may also get benefited from the video. Right, let's get started. So we will pick up from where we left in the last tutorial video. In last tutorial video, we set up the stack up as per our Gerber file. So we have a two-layered stack up and a via hole. Now look at this stack up, which is slightly different than the standard, microstrip or strip line kind of stack ups, because in those stack ups we always have a cover plate at the bottom, and that cover plate acts as a implicit reference for the ground, so that when you place the pins to create ports, you only need to worry about the plus pins. The negative is always taken from the cover. However, in these multi-layer kind of boards or imported Gerber files or DXF files, you don't have that condition. So let's see how can we handle that. And also, when you have multi-layer, 6 layer, 8 layers, or whatever, you need to be little careful how to set mesh and how to handle vias in your EM simulation. Because if you don't take care of that, your memory can go through the roof and your simulation can be really, really slow. So these are some of the tips and tricks you will learn in this video. So hang on and let's start the learning process. Now, once we have the layout, we can select the layer on which we want to place the the pins. Now, once I select the top layer, because that's where most of my conductor is, where I want to place the pins, we can start placing pins by clicking on this icon. And whenever you deal with multi-layer, kind of structures, it's a good idea to switch off the auto layer snap, because that way it will guarantee that whatever is your current selected layers, all the pins will be placed only on that layer. So let's go ahead and start placing the pins in the layer of our choice. So here you don't need to be any specific order. It's your choice if you want to follow a specific order. Here I'm going to place the pins where either I want to see the S parameter results, or maybe in case of hybrid board, I may want to connect RLC or transistors later in the schematic process. So here I'm going to connect the pins at the required places, and approximately, if you see, once I finish placing, I placed 20 pins because now the 21st pin is active, which I haven't placed yet. So after you place all the pins, which essentially will form the positive terminal of your termination, now you need to worry about the negative pin of the termination. And now in this kind of structures, it's a bottom layer where I need to place the negative pin. Now there are a couple of ways. One is the manual way, which is also needed at times, where you can make the bottom layer as active layer. Select the pin, and now we can rotate this pin to see it slightly better. And again, the auto layer snap is off. And for every plus pin on the top layer, I will need to place one minus pin at the bottom layer. So you could either do this way, or you could do copy and paste on a specific layer. That's also possible. But then once you place all the pins, you need to open a port editor. And in this port editor, you need to make the pairing. You can see it detected pin 21 as a separate 50 ohm port, but that's the ground reference for pin number 1 in as per my placement. So this is not a correct assignment. So what we need to do is pick this P21, drag and drop it to GND. Now we will create a termination number 1 between P1 and P21. And by default, the impedance 50 ohm. But if you want, you can go ahead and change the impedance as required. But usually in all our microwave application, we keep it 50 ohm. So this way, when I click the termination 1, you can see both of these pins connected, and that's across these two pins. We will have a termination port for our simulation. So that's way number 1. And this way you can manage all the combinations the way you want. However, there is an easier way out, because this technique is little laborious if you have large number of ports. For example, in my case, I have 20 ports, so I will need to end up making 20 combinations. ADS can do that job automatically. So I went ahead and deleted the pin 21. Now, if I open the port editor again, notice against each port, you have a ground layer. And when it says implicit, meaning it is referring to this GND, but this GND right now has no meaning because I do not have any cover plate or the slot layer in my stack up. So in ADS, I can tell ADS to place the negative pin on the bottom layer for this terminal, and ADS will find the nearest possible point on this layer to place a negative pin for your simulation. And once you have done that, you could just right click, copy, select rest of the ports, and simply right click and paste. With two simple clicks, I have placed 20, or even if you had 50, 100 pins, all of them will have now the negative pin on the bottom layer. So let's see how this looks and how EM simulator will treat it. So when we create a new EM setup, notice I have selected none template, but if you had your own template, it will appear here in the list. As you can see, I have one template, which is FEM for BPF. And later I'll show you how you can save your own templates. So let's start with none. We create a EM setup menu, and you can notice there is no error warning. So I clicked on this 3D EM preview, which is different than this 3D preview, because 3D preview only shows you the geometry in an isometric manner as per your stack up, whereas 3D EM preview will process the geometry as per the EM simulator. And this is what your EM simulator will see at the end of the day for simulation. Now notice with all our settings for every port, we have two terminals defined. We only place the plus pin on the top layer, and with our setting, it has went ahead and placed negative pin. And across those two pins, it has created various ports, which you can see. And this is what we were expecting, and this is what we want. And this is precisely how the EM simulator will treat your geometry. Now, one part of the problem is done. The second piece, which you need to be very careful about in setting up an EM, under options, you go to physical model. In these kind of boards, you can have a very large number of vias. In this case, because I just cut out a small section, so I do not have many, high number of vias, but in your board, you can really have a big number. So you need to be careful. So by default in ADS, the via model is 3D distributed. And most of the time in RF boards, all your vias are typically used for ground stitching. So you could switch the VIA mode to wire, which helps you in reducing the memory requirement, as well as it has the decent amount of accuracy for grounding vias, which you can see on the screen. It will model all the required stuff which is needed for grounding vias. But in case you have a combination of having grounding vias and your RF trace is also having the via, you can go to net specific setting, and in net specific setting you can see you have the net names defined, and when you select any net you can highlight that net. And let's say if this is the net where you have the via going and connecting to the other side, I could go ahead and pick a separate via modeling, for example 3D distributed or a 2D distributed, which provides you required accuracy for the RF vias. So you can very selectively pick and choose where you want to really apply a full 3D current modeling for the VM. Similarly for mesh, by default is a global setting, and in these cases you may have 4 layers, 6 layer or 8 layers, and you don't want to mesh all the layers with a high mesh density like 20 or 30 cells per wavelength. You can set your mesh as per the layer specific job. For example, if I decide all my RF signal traces are on top layer, I can go ahead and set it to a different cell per density. And a bottom layer is my ground layer. I can go ahead and pick a lesser density to that. So that way you can optimize the amount of unknowns which way your simulator will have to solve, saving you a lot of time and memory. Now, in some cases, this setting may not be sufficient, so you can even go to net specific setting. And again, you can only pick the RF nets which really you are concerned with. For example, here I have P19, I have P11, and so on. So all those nets you can set as a good precision. All the grounding nets, for example, here if I select P8, and which is largely all the ground net, And this ground net, I can define it to be, telstar per wavelength. So this will again give me the compromise between accuracy and speed, and I will not consume a very high amount of RAM. So these things are pretty important for us to consider. And once we make this setting and we want to retain this setting for next round of simulation or next iteration on the board, you can go ahead to File, create template, and you can save your own setting. For example, sample RF board, and you can save it as a local or user specific setup in a particular library. And once you create, all these settings get saved for you. And now next time you want to create the setup, you can load the same template when you create a new EM simulation. Now finally, once you have this layout, and if this layout has certain lumped components which you need to simulate, you can create a EM model and symbol. You can follow rest of the stuff we talked about in the earlier tutorial videos, but just for symbol creation, you can click on this icon, create a symbol of the layout, and it will be layout lookalike symbol. And notice all the places where we place pins, you will have the connection point here later to be used in a schematic. Now let's go back to a schematic, and we can create a new schematic for ourselves. And if you want to place that layout in this schematic, we simply drag and drop this symbol. And now you can notice your symbol looks exactly like layout, and there's no confusion which component can be connected where. And now you can go ahead and set up your schematic simulation as you required by connecting the needed components here. So that's all for this video. Thanks a lot for your time. I hope you like the content presented. And again, don't forget to subscribe to the channel, and happy designing.